Hi and welcome to this webinar. We will talk about AI today, and this is actually the first of 3 webinars when we from Columbus will discuss how AI can improve your business. Today, we will focus on a process called demand forecasting process and see how we can apply AI technology to that process. You can ask questions to us in a tool. We will be the only one that can see your questions, and we have a team ready to answer them during this webinar. I would like to start by presenting my colleagues. In the studio here in Stockholm, I have Olivia.
Hello.
And Olivia is a business consultant within our data and analytics division. And then I would like to go to India. And in India, we have Javad, who is a data science consultant.
Hello there.
I would like to start, Olivia, to ask you some questions. We are talking about this demand forecast process, and in your experience, how is company supporting that process today?
Well, I would say in many cases we see companies using a more manual approach to this or an outdated approach. We see a lot of spreadsheet solutions or using rolling 12-month average approach to it. So I would say those solutions are the most common.
It's a little bit surprising to hear because this is an important process of many reasons. But you're saying a lot of people actually are using, or companies are using, like Excel.
Yeah, and there's actually a study made by McKinsey that says that 73% of supply chain executives actually use some sort of spreadsheet solution in their planning.
Okay. So we are talking about demand forecasting, sales forecasting. Maybe we should also, what's the difference between a demand forecast and a sales forecast?
That's a good question. So sales forecasting is an approach where you look at historical sales. So if I were to estimate the sales in July this year, for example, I would look at sales in July the last year. I would also look at an overall trend for last year, and then I would use this information when I estimate the sales this year. So it's a fairly simple approach. It's easy to implement often, and yeah. But as soon as we add any sort of complexity to our organization, this approach, you can actually get some bad results from this, or inaccurate results.
And why is that?
Well, as soon as you add complexity to it, there's more stuff that you need to take into account, and that's why demand forecasting might be better to use. So in demand forecasting, we instead focus on the demand or the willingness of a customer to buy a product at a specific price. And here we often take more things into account. So we can look at new products that's been introduced to the market, or changes to competition, or other things that also might influence the demand.
So let's say that last year you sold 100 pieces of a product, and but maybe you could have sold 200, but you were out of stock, and that's kind of the difference between demand and sales forecasting. Okay. Okay, so now we will look then at how we can apply machine learning to this process, and maybe we shouldn't just assume that everyone knows what machine learning is. So maybe Olivia, if you just could give a short brief, what is machine learning?
Yeah, so very briefly, machine learning is a subfield of artificial intelligence. It gives computers the ability to learn without explicitly being programmed. So the idea is that systems can use data, it can identify patterns in this data, and it can derive conclusions from it. And it also does this with minimal human intervention.
So Olivia, why is machine learning a good technology to apply to your demand forecast process?
Yeah, so it's mostly about accuracy, right? So when we do our forecasts, we want them to be as accurate as possible. And using machine learning, we can process a huge amount of data. We can also see patterns in the data that's very complex. There's also minimal bias. Since there's minimal human intervention, we have less bias from subjective opinions or human emotions. We also live in a fast-changing world, so I mean, the last couple of years are good examples of that. There's a lot going on around the world that affecting demand for pretty much everything. So, well, machine learning won't be able to, or I should say, it probably won't be able to foresee a global pandemic, but it's quick to adapt to those sort of demand changes.
Thank you. So by that, I would like to go back to India, to my colleague Javad. And Javad will now present a solution that we have developed regarding this and give some thoughts and experience from this kind of projects. So please, Javad.
Thanks, Per. Today I'll be speaking on some actual customer work which we did on demand forecasting quite recently. Interestingly, it was an integration of our demand forecasting solution into Dynamics 365. So when we were building our solution on demand forecasting, we wanted to build something that is tech agnostic, and also something that could be up and running in a short period of time, and also applicable to a wide variety of businesses. So let's say, for instance, if you want to achieve more accurate forecasts, but you're using a non-scalable approach, like what Olivia said, working on spreadsheets, and that's where you're generating those forecasts. So that's where we come in. We have our data migration team who can help move your data to a more scalable cloud data lake service. And then we pull in any required data into a service like Azure Machine Learning, and then do the machine learning part and generate forecasts over there. But allow me to come back to the customer story. We at Columbus were working on a business transformation project involving building a completely new business platform. So part of it was also the data migration project. The customer wanted to migrate from a legacy ERP system into Dynamics 365. One of the business objectives of this project was to have a more transparent and efficient supply chain as well. So the customer said that they had forecasting capability on their legacy system, but it was quite limited. They wanted to go for something which is more tailored and which has a much larger scope, is more scalable and also customizable. They want to have control over their forecasts. So then we suggested that they do go for forecasting in Dynamics 365 in the finance and operations module. And one of the reasons for that is because it has an inbuilt connector that allows you to connect this Dynamics 365 ERP system to Azure ML. So initially, we suggested that we go for a proof of concept. And in this, the customer gave us a limited number of handpicked items. And then we came up with our forecasts. The customer then compared our forecasts with those of the legacy system. And they found that we were able to provide lower error scores. That basically means better accuracies in terms of forecasts. And it's only after this that they got the confidence and they chose to go for the full-fledged project. Looking at the slide now, as you can see, initially, before we started training the models, we found that the customer had data in a wide variety of different sources. Some of it was stored in spreadsheets in Excel sheets. Some of it was stored in the database somewhere. And then there were also a variety of different formats. Some of it in Parquet files and some of it in Excel and CSVs. So the first part was where we spent quite a lot amount of time gathering all of the historical data into one place and trying to understand it and see how much of that is actually useful for us, and then integrating all of it into one large table. It's after this that we went for the training of the model, where we followed the entire machine learning lifecycle, right from understanding of the data, preparing the data, wrangling of the data. That basically means cleaning it, removing outliers if you think that there's some errors in the data, if there's some gaps over there, treating all of those, and then training the actual machine learning models. And then this was an iterative process where we tried a number of different models and we tuned them to get the best performances. We trained some classical systems, something like Olivia was saying, where we use time series models like ETS and ARIMA. And we also tried the latest tree-based machine learning models like XGBoost. So in the end, our model is an amalgamation of multiple, which is run each time you get a new forecast. And that's the way we get the best results. And after the training, we have the monitoring of the results, and of course, saving these models and registering them inside machine learning, Azure Machine Learning. Once we started with production, that's where we created the connection between Dynamics and Azure Machine Learning. And this was a great part because it allows the end user, the business user, somebody who's already familiar with the interface of Dynamics, to just create the forecasts and view them directly within Dynamics without getting their hand dirty inside the code or inside Azure Machine Learning. And I'll be showing a quick demo about this at the end of the presentation as well. So once we generate and return the forecasts, they are saved once again back into Dynamics into a temporary staging place. And this is where the end user can look at the results and decide whether they seem correct or not. And then only after that, they can decide to authorize the forecast. So essentially, this was what we did for the customer. And let's say that somebody is interested in having this implemented from Columbus. So I'd like to show you what actually happens and what will you experience when you work with Columbus. So for every implementation service at Columbus, we follow a defined set of steps for smooth implementation. We begin with, of course, onboarding the teams, meet and greet, introductory calls, getting to know all the stakeholders. And then a bit of time is spent on understanding the business needs. Now, this is a very important step of the process. It is first framing of the business problem and coming up with a very clear objective and agreeing on a success criterion. For example, in the POC, the success criterion was to reduce the error results and reduce and increase the accuracies on the past legacy systems forecast. So it's something like that that we determined beforehand. And also, we felt that for this customer, they had very customized needs. A lot of business rules were needed to be defined. And we also had to code in a number of additional rules before we actually went for the modeling part. That's what we did. Next, we begin with working with the actual data, getting our hands dirty, trying to understand it. We see whether a good amount of data is available. We try to see where was the origin of the data? How was it actually produced? And then was it processed before it was sent to us? Where is it stored? What is its flow? And then we try to clarify if we see that the data is not enough to meet the objectives and the pre-decided success criterion. And then we suggest if any external data sets will be required or if there's something missing. And at Columbus, it's not that you give us the data and after a couple of months, we come back and give you the outputs. It's a continuous interaction and there's a continuous improvements happening. And initially, we showcase the results that we have seen from the data. Like, are there any trends? And did we see any gaps in the data? And we'll also show you how are we filling those gaps and how are we treating them. After which, we went for development. The development is, like I told you, the entire machine learning cycle, which we followed in the previous slide. And also, we set up the environments, getting your accesses, and all the legal steps that come in between, since if it is sensitive data. And of course, setting up the connections between Dynamics and Azure ML, like we've done in this particular project. And then rigorous testing happens. We did our own testing the code, the script that we had written, and doing the unit tests and checking for all the edge cases. Are they passing or not? Are the forecasts for the edge cases actually reasonable or not? And then the customer themselves, in this particular case, did an extended period of UAT, user acceptance testing. And only after they were satisfied with that they asked us to go into deployment. And in deployment, we took the solution that we had built for testing and put it into the production environment. And that's how we ended with that. All right, now I'm in the Dynamics 365 environment, particularly in the finance and operations module. So folks who are familiar with finance and operations will be familiar with this environment as well. So that's the best part about it. You don't need to learn a new interface. Now let's say that it's the end of the month and I have all the data from the last month's sales and the demand which has happened. And that is all saved and recorded inside Dynamics. And I want to generate a new forecast. So I would go into an option which is generate a statistical baseline forecast. and just click and select a few options over here. And let's say that I want to choose the data from the past 3 years. The item which I'm interested in has the data available for the past 3 years. So that's what I've done now from 2019 to the beginning of 2023. And I want to see the forecast from the beginning of February. So I choose that over here. Now I have a choice. Do I want to look at the forecast at a monthly level or at a weekly level or at a daily level? So let's say that I want to see one forecast for each month in the future. So I've chosen that. And then I want to see the forecast for the next 10 months. So that's 10 months over here. I can also select what records I want to include. So it might be that you're not interested in all the items that are saved in the system, right? You are interested in only a few particular ones. So that's what I can do over here. And give a sample name and some comments if you want. And then it's as simple as clicking on OK. And once you click on that OK, all the records that you have chosen, all the data for all the past items, and the past historical data for the past 3 months, and all of these other commands are sent to us on Azure Machine Learning. And that's where we do the forecasts. We generate these forecasts and send it back to Dynamics. I was telling you about how Dynamics also allows you to view these forecasts on a screen where you can decide whether you want to continue with those or not. So this is that. These are the forecasts which have been generated and returned from Azure Machine Learning. And as you can see, they start on February and go for the next 10 months until November. And let's say for this particular item, me as a business user, I've been working with this data and this company for the last several years. And I know for a fact that in February, the forecast will not be 47. And I know that it will be, let's say, 107. So I change it to 107. And that's it. That's how I can update the results of the forecast as well. Now I have an option to authorize the forecast and then save it into the actual database. Another great thing is I also get to see these forecasts graphically, visually, where I can compare them with any past historical forecast which I might have, and also the past historical data. So that's what I'm trying to do here. As you can see, these blue lines are the past historical data. And the purple is what the model has predicted as the forecast. And the blue shading around it is the confidence score. This is the next good thing about this. So all in all, this is what we have built for this customer. And as you can see, very easy to use interface, completely using the graphical GUI. You don't really need to get your hand dirty with the code. All of that happens in the backend. And that's what we have delivered. Thank you.
Thank you very much, Javad. That was a very interesting presentation. But I was thinking about one thing here. What about if someone listening into this webinar and don't use Dynamics as an ERP system? Can you use our solution to other ERP systems as well?
Yeah, Per. That can be done as well. Like I said in one of my slides, we wanted to make the solution as tech agnostic as possible. So let's say that you're using Dynamics, fine, you can just do what we had just shown you. Or if you're using Infers M3 or any other ERP solution for that matter, we can still adapt our solution to that approach. So the thing is, as long as we can pull in the data from there, we are good to go. So even if you're using spreadsheets, like Olivia was saying, we first pull the data into a scalable data lake. And it's from there that we push the data into Azure Machine Learning or some service like that, and then do the forecasting, as we just saw. But what happens after that is the different part. So like you saw what we did for this customer, there was a very clean interface in Dynamics, easy to use, where you can generate the forecasts and also view them. So to complement that for our other customers, our BI team here at Columbus has built an application using Power Apps, where it is quite similar to what you saw on Dynamics. It's over there that you can view the forecasts, you can edit those forecasts, and also authorize them, like we just saw in the demo. So if you're not using Dynamics, you're still good to go.
Okay, great. Thank you for that clarification. So by that, I would like to start wrapping things up here now. Thank you, Olivia. Thank you, Javad. And especially thank you for the audience for listening in. I hope that you thought this was valuable. I can hear that we actually got a lot of questions during these sessions. And if you haven't got the answer yet, you will get the answer to your question. You will also get an email with a link for a recording of this webinar if you want to share it with some of your colleagues. I hope that you will join us next time in session 2 of our 3 series webinar, and then we will talk about how to increase product quality in manufacturing with AI. Thank you very much.